Welcome back. So if you've gotten this far, that indicates you're progressing through the videos for Chapter 2. Last time we talked about measurements, why we need to make measurements as a scientist or as a chemist, the different types of measurements we make, and we began to work a little bit with how we can manipulate those measurements, so talking about significant digits, reporting our measurements to the correct number of digits, and we began manipulating those calculations or those numbers that we measure in mathematical calculations. So we're going to finish up Chapter 2 in this set of videos by talking about units. So when we make our measurements, how do we work with the units in which we express those measurements, and how do we convert between different units, which is something you'll have to do quite often when you go through the Chem 1 series. So as you can see here, we're going to talk a little bit first about the metric system. So in chemistry and in most science classes, you'll generally deal with measurements using what we call the SI, or International System of Units, and that's based on the metric unit system. Okay, so here you see a number line where we're showing powers of 10 going from, of course, higher, larger numbers down to smaller numbers. And we've identified a few prefixes, so these are what we call metric prefixes. And what we can do is we can have a specific measurement, so we can have either grams or meters or liters, and we can change the way we express those measurements just by putting different prefixes in front of that measurement. So we could have kilogram to express a large number of grams, or we could have milligram to express a smaller number. And in an analogous fashion, we could use kilometer to express a large distance, or say millimeter to express a smaller distance. And what's nice about the metric prefix system is that this can be readily converted between units simply by moving a decimal point, because these are just powers of 10. So just to give you a couple of quick examples, if we take the milli prefix, so let's say we have 1 milligram, so we've measured a mass of 1 milligram. Based on our prefix metric system, we know that that would equal 10 to the minus third grams, because milli is 10 to the minus third. Now, of course, we generally want to express these as a number versus an exponent if we can. And so hopefully by your knowledge of scientific notation, you now know that this would be 0.0010 grams. So 1 milligram is a small unit, so it's going to be a smaller number of grams. So that's kind of the easy way to remember if you're doing this the right way. So milli is generally measuring a smaller amount. So if we express milligrams and grams, you should get a smaller number. All right, so conversely, we could say that we've measured 1 kilogram. So now we've measured a large number of grams, a large mass. And now kilo corresponds to 10 to the third. So if you memorize the prefix kilo is 10 to the third, we would just say now that equals 10 to the third grams. And of course, if we express that as a number, not an exponential form, that's 1,000 grams. And now if we want to express this with a specific number of significant digits, we could put that back into scientific notation, but where we have a number with an exponential power. So it'd be 1.0 times 10 to the third. So hopefully you can see how you're just using these powers of 10 to change the units. So what I want you to do now is work on this practice problem. So now we have a practice problem where I want you to take the mass of an object that was found to be 245 milligrams, and I want you to express that in kilograms. So even though you wouldn't normally express such a small mass in kilograms, it's going to be good practice for you to convert between these two units. So use the number metric prefix number line and see if you can convert between those two units. So take a few minutes to do that. So pause the video, and then when you're done with that problem, come back and we'll go over the solution.